Okay, hello everyone. Okay, I know we still have 1 minute, but if you have questions, just start putting them on chat so we can go get started. So what questions do you guys have difficulties with in the homework? Did you want to upload the homework report?
Did we need to have anything else printed off for today?
Worksheet 4. There is a worksheet called 4, and that's the one that I will work with. The rest, we will work together in class. You don't need a worksheet for it. All right? Okay. So we start. Amanda had the question number 8, section 1.2. And very good. So we start with number 8, section 1.2. Okay. All right. So number 8. So the question is the following. All right, I read your questions, I know. Let A and B be the set of real numbers, and let F be the function that to each element of A is assigned -2 times the element. So F does the following. F of element, I write what they say, and then of course we're going to write it mathematically. So F of an element is, so F of something is -2 times the element. That's what the problem is really telling me. So that's really the rule. Okay, it means whatever you give it, the rule will, so whatever you give it here, so let me call this X, because that's really what F does. It takes -2 times whatever you give it. So that's really the rule we are working with. So now my questions are, so here's the questions. What is F of 4? So I will not do everything, but I will make sure you understand what we problem. So what does F to do to the element 4? Very quickly, I want answer. Takes -2 times this element. So it's -2 times the element 4, which is -8. Okay, is this making sense? Let me pick another one. I will not pick all of them because it will be waste my time and your time as well. So what is F of what? Okay. What is F of a third?
Can you go over section F?
Please put on chat. What is it? Okay. What is F of 1/3? It's -2 times it with a third, which is basically -2/3. It means -1/3 plus a third, which is -2/3. All right, so as I said, I will not do every one of them. I will do some because, so B. No, I meant G. The question is, what is the rule? What is F of X? Okay, what is F of X? What does F do to X? It's -2 times X. Okay. And then the question is, H. Is there a number such that F of C is -4? The question is, can I find C such that F of C is -24? What are they asking about? I will address those issues later on, those who are asking me about the problems. All right. Can I find C that F of C equals -24? What are they asking us? Input or output?
Input.
Input. It means, can I find an input C? Okay, it means we have to set. What is F of C? It's -2 times C. So we are going to set, this is equal to minus 24 and basically solve for C. All right, to solve for C, I divide by minus 2, which is going to give me minus 24 divided by minus 2. It gives me a 12. It means I'm asking for the input, and the input is 12. Okay. Now, okay, the question is there a number B such that f of B is negative? So they want me to find a certain number that but the output is negative. Okay, so who can give me the B such that f of B is negative? Are there a lot of them? Quickly. Okay, who can give me a B such that f of B is negative?
Won't any positive number make it negative?
Right, any positive number, because what is f of B? It's minus 2 times B. So the question is, can you give me a B such that minus 2 times B negative? Of course. Please don't worry about the homework. Stop chatting about it. Focus on what we're doing. Okay? So, can I find a B such that f of B negative? Yeah, because if B is minus 3, it's negative. B positive 3 is negative. So there are a lot of them. So how can we find them? Okay, we can divide by minus 2 both sides. So I will say minus 2 times B divided by minus 2. Now we have to be careful. If I divide by a negative number, this will have to be changed the inequality. It means B is positive. Sorry. Okay, it means any positive number will make f of B positive. Any positive number will make f of B negative. Okay, any positive number. You put 2, it's negative. 3, negative. Because I have a minus 2, so whenever I multiply by a positive number, I have negative. All right? So let's look a little bit more at this problem, and then we move on. Okay, so again, I will put what the function is. It's minus 2 times the x. So now the question is, okay, I will do k, but I will skip I because I think they are the same. What is f of t plus 3? Because those are questions. Okay, what's f of t plus 3? What does f do? Whatever you give it, it times it by negative 2. So f of t plus 3 is what? Whatever you give it. So if you give it t plus 3, what is f is going to do? It takes minus 2 times it with whatever you give it. Okay, which is you distribute minus 2 minus 6. All right? And then the last question I is the following. Can you find a number that makes f of c greater than 100? It means, can you find numbers such that when you multiply it, the result is greater than 100? Right? Who can give me answers before we find all of them?
Wouldn't that be, it could also be like 100, but also greater than it too?
I want minus 2c bigger than 100. Give me one value of c.
50.
50. Is he right? If I take c to be 50, all right, minus 2c, it means minus 100 bigger than 100. 50 work. Who can give me another one? Who can give me another one? Bigger or equal. So if I take another student, give me 49. Is he right? Minus 2 times 49, which is gonna give me minus 98, right? Is this bigger than 100?
Where'd you even get to -2 from?
That's the output. What's the output? What is f of c? What is f of anything? Is -2
What the fuck?
times this anything. That's my function.
Oh.
Is that clear? That's what my function is. So my
Oh,
question now, what?
Oh, I wasn't paying attention to you. I was actually looking back, and I saw that it was actually already up at the front here. I was wondering
Right.
where
That's
the
the,
C
yeah,
was.
that's the function. So now my question is, I'm asking you to give me C that makes this true. So one of your classmates gave me C to be 50. And now forget about here. Let us make it true. Is this correct? Will 50 do it? Yes or no?
No, I don't believe so.
I don't believe so. I don't know what I was writing here. Nonsense. Because -100 bigger than 100?
It's negative.
No. We can give me a C, another one. Quickly, -50. Will this do it? Yeah. -2. That's what the question is about. Is this true? Yeah. 100 is bigger than 100. So this will do. One more, and then we find all of them. I want another one, quickly. And then we find all of them, because this is kind of tedious. You can give me one more. -51. Let me see if this works. -2 times -51 minus say plus 2 times 51. It's 102. Is it bigger than 100? Absolutely so. So can you find me an input that said f of c? It means, can you make this bigger than 100? So you guys gave me 2. Now let us find all of them. Okay, let's find all of them. It means we need to find all numbers such that -2 times c is larger than 100. Now, how do we solve this little inequality? All right, to solve inequalities, we have to divide by -2 both sides. Okay, now when I divide by -2, what will happen to the inequality? What happens to inequality when we divide by a negative number?
The sign will flip.
The sign will absolutely flip. Okay, very easy. 2 is less than 3, big deal. But when I multiply by a negative, I'm going to make it larger. So this will flip the sign. And this will give me that c should be less than -50. And this will give me all the possible values of c. Okay, so that's first you were guessing, and now we found all of them. Means any value less than -50 will actually give me here -2c bigger than 100. All right? Okay, I'll look a little bit at number 9, that we will be doing a lot along those lines, and you guys are very precise. So number 9. Okay, and JKL. So let's look a little bit at number 9. Okay, and then we proceed. So number 9. I have the following function, f of x, again. And this function—
There's like 8 parts to, there's like 8 plus parts to question 9. Like, what is it? Question 9a, question 9b?
Yeah, the students are asking me for k, j, and l, but I will have a quick look at all of it. Don't worry about that. Because we will do a lot. Those are problem important, and we will have to do a lot of them. So this is my function. So again, we know what the input is, x, and the output is 3x squared plus 5. That's really what it does, okay? And now we will start several questions. So let us say, what does it do to -1? Okay, very easy. We take 3 times -1 squared at 5. Okay, so which is, I don't know, which is 8. Very good. Now, let's do another one quickly. What is f of 1/2? Okay. So it is 3 times a half square plus 5. All right, what is a half square? What's a half square? Quickly. It's a half times a half, which is 1/4 plus 5. Now, we don't like those, so that's 3/4 plus 5. And now we find a common denominator, which is I will talk a little bit about it today. So this is 5, the common denominator is 4, so I multiply and divide by 4. And this would give me 3/4 plus 20/4, which will give me 23/4. Okay, so a little bit of algebra that we have to do in those problems. All right, so now let's look at another, which one? K, J, and L. K, J, and L. All right. So
Actually,
let me do add.
I, K, and L, not J.
What?
Can you do I instead of J, please?
I. We do
Thank
I,
you.
no problem. Is there a number such that f of b is negative? Okay, it means, what does it mean? Can you give me a number so that when I plug it into the formula, that's what we did before, it spits out a negative number. I'm stopping because I want answers. Because I'm expecting you to have done this homework and we discuss it in class.
No.
Somebody said no, and whoever said no has to justify.
If you plug a negative number into the b squared, it's going to make it positive no matter what.
Right, and then what you're doing to it.
You're adding 5.
And you're adding 5. So there is no way you can find a number, what you put it in here, it's going to spit out a negative number. So let us say so. Can find b such that there is, we can't. There are no values of b. Why? Because there is no value. Because when you take any number, b squared is always a positive number or equal to 0, of course. Whether it's a negative or a positive, that's a positive number. So when you take 3 times b squared, you're gonna always have a positive number. It's even more than that. You're adding 5 to it. So it's gonna be a real positive number. So there is no way we can have a negative answer. So the question to this, there is no values of b just by looking at it in this particular problem. All right. What other questions? So we did I, and let us see K, and then I'll stop, and then we move on. K, for example, what is K? Can you find 2 numbers? So the idea here is just understand the function and play with it. R and S. I want 2 numbers. You have to give it to me. So that when I evaluate f at R, I get something. We want it to be greater than the value of f at S. So this is my questions. So remember what f does. Always keep it track. F is 3 times x squared plus 5. And other questions, you can guess, doesn't matter to me. Can you give me 2 numbers, R and S, with R less than S? So R is smaller, but f of R is larger. All right, so some students give me, tell me take -6 for S, for R, and take 2 for S. Okay, let's see if the student is correct. Okay, R is less than S, that's for sure. -6 is less than -2. And what's f of R? So f of R is 3 times what? R is -6 plus 5. And this will give me 3 times 36 plus 5. And 3 times 36, you guys know what the answer is? Three times 6, 18, and this one gonna give me 108, which give me a 113. What is f of s? So we start a new paper for f of s. So this is, the student is guessing, and I'm making sure his guess is right. Now, what is f of s? According to your classmate, he picked f of s to be 2. So f of 2 is 3 times 2 squared plus 5. Very good. Okay, that's 3 times 4, that's a 12. Plus 5 is definitely 17. So f of r is 113, is bigger than f of s, which is 17. So it's really a matter of guessing, looking at the function and guessing, all right? All right, so this take care of your answers. Today we basically going to be working with functions. So we're not really kind of changing the scenario. We keep working with function. So today we will talk a little bit about the graph of a function. So before we do that, we did k. Can we do k really fast? We did k. So k is those numbers that you guys gave me, s and r. All right. So we're going to talk a little bit today about the domain of a function, the graph of a function, and then we will do more problems along the line that I just did. We will do more problems. So what's the domain of a function? The domain is this collection of all the elements that we assign something to. In other words, the domain is nothing more than all the input values. And the problem somehow will give you the domain, at least for the beginning, it will give you the domain. The domain is nothing more than the input value. So let's see an example of that. Suppose I take A, the set of all US citizens. That's my A. F is a function that assigns to each US citizen the number of letters in their first name. So it takes for input US citizen. It takes for input US citizen, and it does something to them. It associates to them the number of letter in the first name. That's what the function does. Okay, so if you want to understand exactly the function, so let us say I say f of norma. I am a US citizen, as I said last time. What is f of norma? 1, 2, 3, 4, 5. F of norma is equal to 5. So that's really what the function is doing. What's the domain? Domain are all the input values. So in this simple scenario, what is the domain of this function? Is this 1.3? It's 1.2 and 1.3 at the same time. So what's the domain of this function? Please go ahead. What are the input? Are they numbers? Are they humans? What are the input in this particular problem?
Citizens' first names.
What? Repeat.
Citizens' first names.
No, the input is not the first name. I mean, first name of what?
Each US citizen.
Right. It means the domain is names of US citizens. That's what the input is. So there are people in this particular case, and they are the name of US citizens. All right, example number 2. Suppose f is a function given by the following table. So it's just a table. 0, 2, 1, 0, 2 minus 3, and 3 minus 5. What's the domain in this particular problem? It means what are the input value here? Quickly. What are all the inputs? So this function takes 0 to 2. It takes 1 to 0. It takes 2 to minus 3. It takes 3 to minus 5. So the domain are all the input value. So in this case, if I tell you what is f of 4, You told me, I don't know what f of 4 is because there is no output for f of 4. So in this particular problem, the domain are the numbers 0, 1, 2, and 3. Okay, so the domain are all the input because this function, a function is going to take a bunch of stuff and assign something to them. The domain are those input, the thing that we assign something to. So in this very simple scenario, the domain is 0, 1, 2, 3. Okay, all right. Now we're going to start section 1.3, and which is about the graph of a function. So what is the graph of a function? Okay. What's the graph? All right, the function, yes. What is the graph of a function? And every time I'm going to talk about the graph, I will go back to the domain. What is the graph of a function? The function is given to us, as we've done before, by like a simple formula. So when we take f of x equal, so when I took f of x equal 3x squared plus 1, or plus 3, or plus 5, this is a function which is given by a rule. I give you the input, and the rule will give you the output. So you give it 1, it spits out that. So that's one way a function is given to us. Another way a function is given to us usually by a simple table. You know, this is, I just gave you a bunch of tables. Another way, if the rule is given to us by, by word. I tell you, okay, it takes every citizen to the number of letters. A lot of time, the function will be given to us by a graph. So what does it mean it's given to us by a graph? It means the following. The graph consists of a picture, the way you see it. On the horizontal axis, here we put the input values on the horizontal. And on the vertical, we put basically the output values. Okay. And the question is, how does a function give me the rule? It means, how does the function tells me 1 goes where, 2 goes where, 3 goes where? That's really what the rule. So how does a function do that? A graph do that? So suppose this is 1. What is f of 1? What's the rule? From 1, you take the vertical distance till you hit the graph, right there. The rule is given by this vertical distance from 1 till you hit the graph. So this is f of 1. So that's how the rule is given by a graph. So this point here, as you see, this is 2. So what is f of 1? It means what's the vertical distance from the x-axis till we hit the graph. So this point here, right there, is coordinate are 1. The other coordinate is f of 1. Okay, let's take another. So that's how a graph gives me the rule. A graph gives me the rule by telling me for every input where the values are on the x-axis, the vertical distance will give me the output. That's how it works. So let us play a little bit with that and proceed. So let us say I'm asking you, what is f of 6? So I tell you a function is given by a graph. It means I'm giving you a way to see the assignment. So if this is a 6, what is f assigning to 6? You go from here till we hit the graph, right there. Right there.
Is it assigning
This
3?
point here, the distance will give, which is according to us, what is this point right there? This is f of 6. And everybody is telling me this is equal to 3. So that's how the rule is given by a graph. So this point here on the graph, what are its coordinates? The first is the input. The second is the output. It means the second is f of 6. So that's what by a function given by a graph. That's what a graph represents. So let us take another value, for example. So what is f of minus 5? Okay. How does this graph is giving me the value at minus 5? Okay, it's minus 2. Do we agree? This is minus 5. The input is here. F of minus 5, it means I go from here all the way down. That's how the rule is actually given to us. So f of minus 5 is equal to minus 2. Okay, so that's how the rule. So every point on the graph. So if I take this point, let's see what this point is. This is 11. So the first coordinate is 11. The second is the output. So that's the input. The first code. The second is the output. So this is 4, and that's the output. So this 4 is the output for 11. So the graph of a function is basically all the points, very specific point. The point have 4 coordinates. Whatever the first coordinate is, let me call it whatever, let me call it a C. The second coordinate is the output, a C. So that's really what the graph is. All right. Let's ask you very simple questions here. Very, very simple question, nothing hard. Is the following. Suppose I have the graph that we see here, and I ask you the following. Find all values of C such that f of C is equal to 5. Find all values of C such that f of C is equal to 5. Very good. This is the graph in front of you. What am I giving you in this problem, and what am I asking you to find? I'm giving you the output, and I'm asking you to find which input will actually spit out an output of 5. So let us go to the graph itself and start figuring out. Output values are put right there. So that's, I want 5 to be my output value. Very good. So now the question is, what are the X values that gives me an output of 5? So basically I want the output of 5. This is my 5. Okay, this is the point on the graph, and 5, this is my point on the graph. So my question is, which are the input? Okay, that's one of them. That's what I am after. That's the 4. What's the other input? Okay, if this is 10, this is 11, that's right there, the 5. So it means it seems to be 12, which is missing right there. So what is the C such that f of C equal to 5? We have 2 of them. The C equal to 4 and the C equal to 12. So graph is nothing more than another way of representing a function. Instead of writing a formula, we can sit down and sketch all the points, the input, the output for this input. Now, I will relate this to the domain. What is the domain of this function? Okay, what is the domain of this function? The domain are, so let us assume my graph doesn't go on till infinity. So my graph actually goes from here to here. And usually I will tell you whether my graph goes from infinity or not. What is the domain in this here? The domain are all the input that there is an output for. So for example, in this particular problem, if I tell you what is f of let us say 14, is there a way for you to tell me what it is? This is 12, 14 is somewhere in here. What is f of 14? I don't know. My graph is not telling me. No, exactly. So what is the domain? The domain on this particular simple scenario are all those inputs. The inputs are here, such that you guys can tell me what the output. So what is the domain in this problem? Let me ask you questions. So that's -5, -6, -7, -8. So in this problem, if I tell you f of -9 in this particular graph, can you tell me what it is? -9 in here. I don't know what's the output. So what's the domain here? The domain is going to be all the values of x, or the input value, but where is x? What's the largest value that you can give me an output for? And what's the smallest value you can give me an output for? So I will write the domain here. What's the domain? All the
-8 to
values
12.
of x. What's the largest value you can give me an output for? What is the largest value? Anybody? 11. What's the smallest value you can give me an output for? -8. So this is the domain. The domain are all those input that I can give an output for.
How's
So
come it
that's-
wouldn't be 12 for the
What?
largest? How's come it wouldn't be 12 for the largest?
It is 12. Thank you very much, actually. It is 12. Okay, because we have value all the way up to here. So the domain is not really, it's just what the input is that for them there is an output. And that's an idea that it shows up in 1.1, 1.2, 1.3, all the way to the end of the course. It means where are those input values? All right, very good. Now, to make sure that you guys get the graph very well, which is I think you can, I want you to take the worksheet that I've asked you, basically to worksheet number 4, and we're going to do it together. I mean, not together. I'll give you a minute to answer, and then I will proceed with the, make sure you guys can do it. So I give you a minute for all of you to get part A, okay? So all of you have the worksheet. If you don't have it, just look at bright space, it's right there. So I want all, because it's hard for you to see from here. I want you all to do A for me. We take a minute because that's how much we need. Okay. Okay. We ready? Are you guys ready?
Yeah.
Yep. So let us start. F of -3. Remember, the input values are right there on the horizontal axis. This is picks up the output value. So f of -3, what it is? What's
12.
the rule? You go all the way up. I'm a little bit slow. I don't see right there. This is the point. The first coordinate. The second is the output at -3. It means from here to here, this is f of -3, which is 10. Very good. What is f of 0? Again, you locate your 0. That's an input value. -3 up to here. F of 1, quickly again. I locate because I don't see as much as you guys. You guys, of course. All right, so from here to here, I have a -4. What is f of 2? Anybody? -3. So that's how the rule is given. So the rule is given in a very easy way on a graph. Now, question number B. Find all numbers C such that C equal f of 3. How many are there? How many value of C are there such that C equal f of 3? What's given to us now, and what are they asking us for? 1 because what is f of 3? So, oh, no, Travis. Be very careful. Find C such that C equal f of 3. It means C in this case, is it an input or an output value? C here, it's f of 3. It means C here is an output value. It means basically the C here is the output value. It is f of 3, which is equal to 0. Okay, so we always have to make sure, are they asking us for what's the input or the output? Here they're asking us for f of 3, which is an output value. Now, find all numbers, all the C's, such that f of C is 0. Are they asking us now for the input or the output values? All the C, such that the rule take them to 0. Absolute to the input. So now let us go after them. So I have the output now. So now the output is 0. I need to find the input. Okay, now, so, okay, everybody is giving me answers. I didn't do this problem. That's the output is 0. I go back. Okay, it's -1 and it is 3. Okay, so I have 2 input, -1 and 3. Very good. So now D, find all the numbers C such that f of C equal -6. Again, are they giving me the input or the output values here? I want all the C's. That's that f of C is -6. It means I know the output and I want to find the input. And everybody telling me it doesn't exist. Let me see if you are right. The output is -6. Output values are on this axis. And I want to find every input. Okay, I don't know. There is none. There is none. Because the graph tells me there is none. So the question is not possible. And the students are absolutely, there is no C, no value of C such that f of C is -6. Okay. Now, again, find all number C such that f of C equal to 5. Again, here I want the output to be 5, so I have my output and I am after my input. Again, I will give all of you 1 second, 30 seconds to give me the answer. Please, all of you do it because I know this is simple, but I want to make sure every single one of you can answer. So now I want, let me rewrite it here. I want the C's such that f of C is equal to 5. Okay. So, all right. So I need the input. I need the 5. Okay, answers? -2 and 4, is Christian correct? Let me check. 5, it means this is my output. That's what's given to me. And I want this to be right there. So these are the inputs. So this is one input, it's a 4. And that's another input, which is -2. -2 and 4, those are 2 different inputs that are giving me the same output of 5. Okay, there's different input that give me the same output of 5. Now my last question is, what's the domain of f? So Brianna, I don't understand the question. Okay, what's the domain of the function f? It means, again, the same question I'm asking. Let us assume, so that's what I'm assuming now, that my graph is what you see is what you can answer. So that's really what you can see. So what is the domain of f? It means which input values you can actually give me an output. Okay, from -3 to 5. So probably some students are going to argue with you because at -4, up there. So the smallest value will be the -4. And the largest value, and when I'm giving you this on a test or something, you make sure this will be very clear. And all the way to here, all the way to 5. So that's the idea of a domain that, as I said, is going to be a recurring topic. Every time I have a function, I ask you what is the domain. It means every input, those are the input that I can have an output for. All right? So that's really the graph of a function. So that's how a function can be definitely given. Rule could be given just by a picture. All right. What is E? The answer to E, you mean?
Professor.
Yeah.
I don't know if this happened for anyone else, but the last two E and F of
Yes, yes, you're absolutely correct. I did change it.
okay, because I printed
Thank you
it out.
very much. Thank you very much.
Yeah,
You're
mine's
absolutely
different
fine.
too.
You're absolutely fine. I did change it. Okay, I did do that. All right. Any questions about this worksheet? Okay, so I will assign homework that actually deal with the same idea for next time, and you will be quizzed on it. Now, what we're going to do right now, I don't want to confuse you at all. In the book, there is 1.4 and section 1.5. Those two sections are basically about called algebraic skills. It means the goal of those sections is to develop your algebraic skills. The way I will do that, I will actually not do 1.4, 1.5 directly because I don't want you to sit down and do a lot of drill algebra problem. What I will be doing is the same. I will be skipping to section 1.6, but the way I will do that is as follows. I will be reminding you of the basic algebra rule, and then I will do problem from 1.6 where you will need those algebra rules. So basically the problems will be from 1.6, but I will remind you the rules that we need to be able to do those problems. All right? And for those who would like to refresh their algebra skill, they can do 1.4, 1.5. Okay, so this being said, 1.6 is again functions, but functions a little bit more complicated, I would say, not much, but to be able to answer some of the questions, we have to have a better algebra background. So I'm going to review some algebra with you today, and then I will do a problem from 1.6 to just tell you that we're not doing anything different. So I repeat, 1.4, 1.5 are algebraic skills that I will build them up throughout the course instead of spending 3 weeks doing them. So this being said, we are going to review your favorite ideas. We're going to review fractions. All right, I know a lot of you know them, but I definitely would like to remind you of them. So we're going to review fraction. That's really what I would like to do. And once we do them, I will take a problem from 1.6 and use what we've learned. So let's review fraction. The first thing we review in fraction is actually adding fraction. And this will be a quick review because most of you have seen it. All right, so I will do a very quick review. Let us say I have the following two fractions, very simple one. 1/7 plus 4/7, all right? So it means if you have a piece, it divided into 7 pieces, you have an object, you take 1 over it, and then you take 4/7 of it. Naturally, in this case, because the denominator is the same, I can combine the numerator and giving me 5/7, all right? Now, let us say I have two fractions. So very quickly, a half plus a third. Right? Now, the minute the denominator is different, I have an issue. So in this case, to be able to add the numerator, I need to find a common denominator. I want to write them under the same denominator so I can add. So we look for the common denominator. Okay, what's the common denominator in this? It means what is the number that is a multiple of 2 and a multiple of 3 immediately? 6, of course. I'm not even pretending you don't know this stuff. So it's a 6. So it means to get 6, this has to be multiplied by 3. It means the numerator has to be multiplied by 3. This 3 has to be multiplied by 2. It means the numerator has to be multiplied by 2. All right? And this will give me 3 over 6 plus 2 over 6. And that's the goal of a common denominator. Then I can combine those, which would give me 5 over 6. Okay? Very good. Now, what I do for numbers, I can do for symbols. What do I mean by that? Let us say I have 2 over x. All right, and I add to it 3 over y. And I want to find a common denominator. Okay, we should not let symbols bother us. What is the common denominator in this scenario? Okay, it means what is the thing that is nothing more like before? It's the product. It's x times y. All right, so now with this in mind, I will find this as a fraction. So this is my x. I have to multiply this by y. It means I have to multiply my numerator by y. Sorry, by y. Yes, sorry. And this is a y. I have to multiply it by x. It means I have to multiply my numerator also by x. Now, in this scenario, I have the same denominator. I will be allowed. Very quick review of fractions. Let me give you 2 more. I want you to do this yourself. So suppose I give you the following. 2x over x minus 1. And I'm going to add to it 3 over x. Okay, and my question to you is basically find a common denominator and write it as a fraction. So all of you, you have a minute to do that. And proceed. Okay, so immediately you write the common denominator in here so we can make sure we all know it. Okay. So what's the common denominator, guys? What did you find? What's going to be the common denominator, you think? I'm not having answers. Right, it's the product. Whatever here times whatever here. That's my common denominator. So it's going to be x multiplied by x minus 1. It's just a product. That's what you do that. So let's see, this will give me what? So now to find a common denominator, what we have to do? This is x minus 1. It has to be multiplied by x. It means the numerator will have to be multiplied by x. Plus, again, x, we have to multiply it by x minus 1. It means my numerator will have to be multiplied by x minus 1. The rest, once I have a common denominator, the rest is ready to combine those. So now I will combine them. I will have x times x minus 1. That's what here. In the top, 2x times x is of course 2x squared plus 3 times x minus 1. So finally, I can distribute and this would give me that. Out of the problem. All right, so the whole idea of adding is basically creating a common denominator. And then once I create that, the rest is actually kind of simple. So let us keep going along the same line. let me ask you this question and 2 more questions with adding, and then we proceed to the rest. Suppose I give you 3 halves and I add to it 5/6. Very simple problem. What is the common denominator in this situation, or the least common denominator? Means what is the number that's a multiple of 2 and 6, but the smallest one? Everybody is telling me 6. So if we want to find a common denominator here, 2, I have to multiply it. So the common denominator here is 6. So 2 has to be multiplied by 3. So I need to multiply the numerator. And this has to be multiplied by 1. And now I proceed. It says 6, 9 plus 5, giving me 14/6. Okay, very good. Now I move to symbols. So the idea is moving from numbers to symbols. So let us say now I have 1/x. And I'm going to add to it 4/xy. Okay, and I want to combine them as a fraction. What do you think is going to be the common denominator? What's the number that is a multiple of x? Okay, it's actually x times y. That will be the common denominator here. So now, because I have x here, I have x times y. So y cannot be a common denominator. The common denominator is x times y. It's like the 6 here. Why 6 was the common denominator? Because 6 was 2 times 3. So the least common denominator is going to be 2 times 3 because that's a multiple of 2. Here also, xy is a multiple of x because it's y times x. So this will be my natural common denominator. The rest is, once I know what my common denominator I do. So this is my x. I multiply it by y, I have my common denominator. So I have to multiply this piece by y. And then here, I do the same. But here, the common denominator xy, so I don't have to multiply this 4 by anything. Once I am there, so now I can actually add the numerator. So my denominator is xy, and this is y plus 4. Okay, let me give you one more question. So my question is the following. I want you to do it. Suppose I give you the following. So what I'm doing now, it's a review, so I can work with functions with you. So suppose I have 3/y plus 5/, let me see, y square. Okay. So what do you think the best common denominator is going to be here? Means something which is a multiple of y and a multiple of y square. All right? What do you think? Absolutely, y square. Y square will be my common denominator. And then what this would be giving me. So this will become 3y/y squared plus y/y squared, which will give me 3y plus 5/y squared. All right, so that's a very quick review for actually adding fractions. Now multiplying them, I will remind you of the rule and divide them. Usually the students know the rule for division. And then we take a function, basically, and start working with it a little bit. So let us see how to multiply, or the rule, how to multiply fraction. Okay, so let's see what's the rule, and then we apply. Suppose I have 2 fractions, a/b, and I multiply it. There is a multiplication here by c/d. How do we multiply fraction? Okay, it's we multiply the numerator over the product with the denominator. Make sure that's a plus. We're not adding anymore. It's a whole different ball game right now. So fairly simple. If I tell you what's 2/5 times whatever, 7, 9, it's simply you multiply 14 over 45. Okay, now of course you're going to use symbols, but that's really the idea. So let us say I have 2 times 7 over 9. So now I'm changing a little bit. So I don't have here a fraction. 2 times 7 over 9, it's equal to what? I mean, you can think of it as 2 over 1 times 7 over 9, which is 14 over 9. Or you can think about it as twice 7 over 9. It means 7 over 9 plus 7 over 9. Okay, so if you have A times B, C over D, it's you multiply AC divided by D because that's the denominator. Now another thing about multiplication, let us say I have 2 over 3, let us say to the power 2. Okay, this is equal to what? It's 2 over 3 times 2 over 3, right? Simple. Now how to multiply those? It means 2 times 2 over 3 times 3. But this means what? 2 square over 3 square. So do not think about fraction. If you have A over B and you raise it to a power, 2, 3, 4, any power. So n is a power. It means A to the n over B to the n. All right? So this is how to multiply them. And the last thing is we're going to recall how to divide them. So that's our first algebra review, how to divide fraction. We proceed as follows. And this is usually all the students remember it very well. What is A over B divided by C over D? It's A over B, you times it with D over C. Okay, and we know what does it mean to times it? It means AD over BC. So if I'm dividing 2 over 3 over 5 over 7, that's 2 over 3 times 7 over 5. Now that's a multiplication. It means that's 14 over 35. Okay, so that's really the quick review of how to deal with fraction in case we encounter them. And so suppose now I'm in section 1.6 as I made myself, hopefully you got it. So now let us apply this to the ideas of function and let's proceed. So now suppose I have the following function. I tell you f of x is equal to, that's the rule. So f of x is x squared plus 2x, let us say minus 15. So this is section 1.6 example. So 1.6, we know it. It's just a little bit, sorry, did I do a stupid algebra mistake? I must have. Okay. So if I did a stupid algebra mistake, it's my issue. So the section 1.6 is nothing new. We're still working with functions, but usually our functions given by a formula. And the goal is, to improve our ability to deal with them. So this is my function, and I'm going to ask you several questions to, So the first question is always my easy question. What is f of 2? It means this is a function. What does it do to 2? Okay, now this is easy. This is an input. It's square the 2 plus 2 times the 2 minus 15. So it's a 4 plus a 4 minus 15. It's an 8 minus the 15, which is how much? Minus 7, I guess. Am I right? Yes. All right. Now, 2. What is f of minus a third? I'll give you a minute to do it. And I want the answer as a fraction. I want the answer as a fraction. Okay, that's why we worked a little bit with fraction, because my goal is to be able to deal with it. All right, so I will work it out with you as you guys are doing it. I want the answer as a fraction. Get going. Okay, I'm getting good answers. I'm getting not the same answers. All right, anybody else? I have 2 answers now. I have to figure out which one is working. I really don't know. Kayla, we see one is dominating. Others? Okay, let me see. Let's see which one is the one correct. I don't work them. I want to work them with you. So x is 2. So it means the whole quantity minus 1/3 squared. Okay, plus 2 times multiply it by minus 1/3 minus 15. So it's equal to. Now what's minus 1/3 square? It's minus 1/3. You times it with minus 1/3. And we know how to multiply them. So basically it's minus 1/3 times minus 1/3. Minus minus plus, and it's 1 times 1/9. So this is 1/9. This is a minus here. 2 times 1/3, 2 times 1/3 is 2/3 minus 50. Okay. Now a common denominator. What's the common denominator here? The common denominator. There is a 9 and there is a 3, and this is really, it's a 1. So the common denominator, the least one, is actually 9 in this particular problem. So that's okay. So now this is 1/9 minus 3 has to be multiplied by 3. So this should be multiplied by 3 minus. This should be a 9, and that should be 15 times 9. Okay, so I'm actually slow. So the whole thing, so I'm 9 across the board. I will have a 1, I will have a 6, and I will have 15 times 9, which is 135. I picked up my calculator for that. And now it seems that 135, you take away a 6, 149, you add 1. So this seems to be minus 140/9. So those group of students got it right. Okay. So let us do one more questions, and then actually I would like to do 2 with you. Now I'm moving to symbolism. It means, so instead of taking, let us say, f of 2, suppose I tell you find f of t plus 1. So the idea here is start working with function bit symbolically. So let's do the setup. And once I do the setup, and then we do the math. So let's do the setup. So I take a nice piece of paper, another one, and we'll do the setup together. So what is f? I always put f. What does f do? It's square 2 times minus 50. And I'm asking you, and this is, we have to work with function also symbolically. What does it do to t plus 1? So very good. Okay, you guys have a minute to look at it, and then I will take it. First, you set it up. Once we set it up, and then we do the math. So that's my input in here. That's the input. Okay. Set it up first correctly, and then we do the math together. Okay. X is to t plus 1. Everywhere there is x. Everywhere there is x is 2, so that's to t plus 1 squared plus 2. Every time there is x, it's my 2t plus 1 minus, let's say 15, nothing. So that's the setup, okay? Now we're going to do the math together, all right? It means I want this to be simplified. How shall I simplify it? What's 2t plus 1 squared? 2t plus 1 squared is this. It's 2t plus 1 multiplied by 2t plus 1 plus 2 times 2t plus 1 minus 15. Then I will distribute everything. Distribute. 2t times 2t, 2t times 2t is 4t squared plus 2t times 1, it's 2t plus 2t plus 1 plus 2 times 2, now I distribute here. It's 4t plus a 2 minus 50. Okay, so we actually to distribute everything. Once we distribute correctly, then I start combining what we call the like term. 4t squared is 4t squared plus, all right, 2t from here, 2t from here, 4t from here. That will give me 8t. And then plus 1, plus 2, that's a 3, minus 15 will give me a minus 12. Right? So that's how we will work with those functions in a symbolic way. My last one is the following. I want you to, a little bit harder, but not that bad. Let us say I put 1 over t in here. Again, the idea is to work with them. So my question is, find an expression and simplify it. So I would like you to set it up, and then I'll set it up with you. So you guys set it up. We have enough time. We have 3 minutes. We should be able to handle this problem. Okay. So I will set up and you see if you guys set it up correctly. So what should be the setup? Instead of x, it is the 1 over t squared plus 2 times, that's it, times, instead of x, it's the 1 over t minus the 50. So that's the setup. Now, okay, I should have written this in red. I forgot. Now we have to write this as a fraction. So that's the second part of being able to do the algebra. So how I'm going to write this as a fraction? First, we have to multiply it. What's 1 over t squared? So as I said previously, 1 over t squared is, you're taking this squared, it means 1 over t, you times it with 1 over t. which is 1 over 1 times 1, 1 over t squared. So the first term is 1 over t squared, and then plus 2 times 1 over t. So 2 times 1 over t is actually, you can think of it as 1 over t plus 1 over t, it means 2 over t, or this is like 2 over 1 times 1 over t. It means 2 times 1 over t. So this is 2 over t. Once I simplify it like this, finding a common denominator will be fairly simple. So finally, what do I get? Now, I need to find a common denominator in this expression. So what's my common denominator? Okay, so I have t squared, you have t, and here I have a 1. That's really what it is. So what is the common denominator in this expression? Go ahead. What is the number? What's a multiple of t and t squared? It's not t, it's not t, it's t squared. Okay, because t, I have t squared here, so it's like if you have 1 over 9 and 1 over 3, the common denominator should be a multiple of 3 and a multiple of 9. If I pick 3 as common denominator, it's not a multiple of 9. So the common denominator here is the t squared. It's still exactly like this situation. The common is not 3. The common is actually 9 because it should be a multiple of both of them. Now, once I figure out that this is the t squared, it will become, so this is 1 over t squared plus. This expression is, that's a t, to get a t squared, so this has to be multiplied by a t. That's how I get my t squared. It means my numerator will have to be multiplied by a t. Minus 15, I have to multiply here numerator, denominator by t squared. Now, once we do that, now I am comfortable writing common denominator is t squared, and that's what give me the 1 plus the 2t minus the 15 t squared. Okay, so we're working actually with function, but we need this algebra background to be able to work with them. So what today I decided that we review fraction, and then we use fractions to be able, we're working with functions, but we introduce a lot of fractions to be able to work with them. All right. Okay, I think my time is up. Now, I know that you're wondering about the homework a lot. We have online homework, and a lot of you must have received some kind of email from Moodle that for the online homework. Now, I'm still working on them to figure out how to embed it into the course. So I will work on them hopefully this week and during Labor Day weekend, and hopefully by next week I can start giving you online homework. Okay, so I know all of you are wondering what to do with the homework. We have it online. It was set up for us like late last week. I have to work on it to see how well to embed it for you so you get the benefit of it. But I need a little bit of time to be able to figure out exactly how I'm going to embed it into your course. So what I explain and the homework will actually go hand in hand. Now, for the time being, for Thursday, you will have the quiz as usual, and I will assign homework. You don't have to hand them in, but as you very well know, my quiz will be based on what I assign. So the homework I'll assign for Thursday, you will do it, hopefully. You ask me questions as usual, but you don't have to hand it in. So hopefully I'll figure Moodle, and then next week I will move to online homework. Does that make any sense to you?
Yes.
Okay. Okay, so the homework will be on Brightspace right after the finish, and the homework will be about section 1.6. And what 1.6 is exactly the type of problems I gave you right now. So you have to use fractions to be able to work with function. That's what 1.6 will be about. There may be one question that you may struggle with. I really don't know, but it's not a big deal. I will be working on that on Thursday. Any other confusion, please speak up.
So just to clarify,
Yes.
we don't have to turn in the homework. Do you want us to just hold on to it just in case when we finish it?
Yeah, just
Okay.
do it because that's the only way you want to learn. I mean, there is no other way that you learn if you don't do the homework. And when I'm going to
Okay,
give you a
right.
quiz, I'm going to really base it on the homework. All right. And
Okay,
as I said, we
okay.
have an online one, but I'm still figuring it out how exactly, you know, to embed it into your course so you get the most benefit out of it. But I need time because I've never used it before. It's very new to us.
Okay,
All right.
thank you.
Make sense? Okay. Thank you very much, guys. And remember my office hours and please just drop by anytime. Bye-bye for now.